All right, today we're going to be learning about electron configuration. If you find this video difficult and you're a little bit confused, I really recommend watching the electron dormitory video I've also posted. It covers the same concept, but in a non-chemistry sort of way, and a lot of students find it very helpful. You decide whether you need it or not at the end of this video. So electrons are arranged in energy levels, sometimes also called shells, around the nucleus of an atom. The first shell can hold a maximum of only 2 electrons. The second shell can hold a maximum of 8 electrons, and the third shell can hold a maximum of 18 electrons. As far as the energy levels are concerned, the further away from the nucleus means that there is more energy. There is no in-between energy levels. You're either on one energy level or you are on the next energy level. And you can see that we increase as energy as we move up through the energy level. So the first energy level has less energy than the second, moving all the way up to the fifth. So energy levels have sublevels that we call subshells, and each subshell has something that we call orbitals. And then our valence electrons are whatever electrons are in that outermost energy level. So every orbital can hold up to 2 electrons. Now let's take a look at this table. So as far as our sublevel is concerned, we have 4 sublevels: S, P, D, and F. As far as the number of shapes, how the orbitals can appear, S has 1, P has 3 different shapes, D has 5 different shapes, and F has 7 different shapes. The max number of electrons that an S sublevel can hold is 2, P can hold 6, D can hold 10, and F can hold 14. The S level energy level starts at 1, the P energy level starts at 2, the D energy level starts at 3, and the F energy level starts at 4. And here are some pictures that I was talking about. You can see there's only the 1 S shape. There are the 3 P shapes, the 5 D shapes, and the 7 F shapes. F looks a little crazy, doesn't it? So there are 2 ways to represent the atomic structure of an element or a compound. The first is electron configuration, which we are going to be focusing all on in this video. And the second is orbital diagrams, which is for your second video of this unit. So let's talk a little bit more about electron configuration. It is a form of notation showing how electrons are distributed among atomic orbitals and energy levels. The format for writing a series of electron configurations includes a series of number, letter, and then a superscript number. And we're going to be talking about where those come from coming up. So for example, number 1, letter is S, which is always going to be our orbital, and the superscript number 2. The electron configuration, known as the standard notation for fluorine, is 1s2, 2s2, 2p5. You can once again see we have our energy level numbers in front. We then have our subshell letter, and then we have the number of electrons is going to be that last one. I really highly recommend in your notes that you put all of these labels onto that standard notation of fluorine. So when you look at a periodic table, it has this basic shape, and we can fill in that shape to represent all of our different energy levels. So let's look at the box on the periodic table. Our S's are in those first 2 columns. You can see we start with 1s, exception being helium, picks up that other kind of block there. Our P's are on that block on the other side of the transition metals. Our D's, which you notice D starts with 3, so it is off from our S's and our P's, are all our transition elements. And then F are our lanthanide and actinide series. They start with 4, even though they're picking up in that 5 level. But all we're doing is moving across the periodic table, and whatever your finger hits is what you write down. So it is really straightforward if you memorize that this is how the periodic table is laid out. Keep in mind, S starts at 1, P starts as 2, as I already laid out, D starts at 3, and F starts at 4. So let's talk about how we would write an electron configuration. We're going to use selenium as our example, so make sure to get out a periodic table and find where you would put where selenium is. So you should have found selenium, atomic number 34, on your periodic table. So we found the element that we are looking for. That is always step number 1. I always put my finger on it just so I don't lose it as I'm looking around. Right there. So we always start with hydrogen. So pretty much you keep moving your finger across each row until you get to whatever element you have placed your finger on, in our case, selenium. So we're going to start up there. Then we are going to write the energy level, number, and letter of each one that we go across. Then we're going to write the superscript of the number of electrons we pass in that section, literally the number of boxes. You are just counting the boxes on the periodic table to get the desired element. So you can see your answer already on the bottom, but let's go through it together so you can see how you got it. So if you start your finger up at hydrogen, you move through hydrogen and helium, that is the 1s2. Then we go back to the beginning again with lithium. We go through lithium and beryllium, which is 2s2. I keep dragging my finger across the periodic table. Since our transition elements are farther down, my finger didn't hit them, so I don't count them yet. And I am on 2p. I drag all the way from boron through neon to get 2p6. It is literally 6 boxes. Then I go back to the beginning again of the periodic table with sodium. Sodium and magnesium is our 3s2. Keep dragging my fingers across. Getting to aluminum through argon is our 3p6. Back to potassium. Potassium and calcium are our 4s2. Now I've hit those transition elements. Remember, the transition elements start with D, the 3. So as I move my finger through 3D, I go through 10 elements. So I write 3D10. And then I go back to 4P, because remember our P's and our S's are in sync with each other. And I hit 1, 2, 3, 4 boxes into P to write 4P4. Once again, just counting what you've gone through on the periodic table. All right, I want you to pause this video, seriously, pause it, and I want you to try to write the electron configuration for beryllium, cadmium, bromine, iodine, and iron all on your own. So unpause the video when you are done. If you feel like you don't know how to do this, rewind and watch the earlier part again. All right, let's check to see how you did. For beryllium, you should have gotten 1s2, 2s2. Pretty simple. Cadmium took it up a level. For cadmium, you should have gotten 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p6, 5s2, and then 4d10, landing on atomic number 48 for cadmium. This is our electron configuration for bromine. Once again, finding Br on the periodic table, number 35. This is the electron configuration for iodine. It is 5 past cadmium, which is why the only difference between it and cadmium is the 5p5. And our last one, iron, atomic number 26, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. We can also do electron configurations with ions. So when doing electron configuration with ions, you write the configuration, and then you add if it's an anion or subtract if it's a cation, the charge from the number of electrons. Sometimes this is going to cause you to go back to a previous energy level, and that's okay. An example, if we had O minus 2. Previously, if I had just said, give me the electron configuration for regular oxygen, you would have written 1s2, 2s2, 2p4. But since it is a negative, we need to add 2 electrons, so we get 1s2, 2s2, and we always add to the end for 2p6. It's simple enough, but I want you to pause this video and try these on your own. I'll give you a hint. If you notice a little bit of a trend in your answers, you probably did it right. But come back to check your answers when you're done. All right, so we had calcium plus 2. So that means that we would have written out our electron configuration for calcium, but then we had to remove 2 electrons. And in this case, it actually removed the entire 4s orbital. So this is our electron configuration for calcium. Meanwhile, phosphorus, atomic number 15, if you found it on the periodic table and wrote out the electron configuration, since it is a -3, that means we add 3 electrons. And when you do that, oh look, you got the same electron configuration as you did with calcium 2+. So keep in mind, electron configurations don't necessarily tell us what element we have because we could be dealing with an ion. Only number of protons tells us what element we have. For magnesium 2+, you took your magnesium and you had to subtract 2 electrons from it, giving us this electron configuration of 1s2, 2s2, 2p6. And last, if you did fluorine -1, that means you took what you had for fluorine and you added 1 additional electron to it, giving us, once again, that same electron configuration. The last kind of notation we're going to talk about today is noble gas notation. And most students actually love noble gas notation because it gives your hand a break, which is why a lot of times it's called shorthand notation. So how you do noble gas notation is you use the last noble gas that is located before that element on the periodic table. If you're doing a noble gas, you have to go all the way back to the previous noble gas. You can't just cheat. So if we were talking about magnesium, we go back to neon, since that's the noble gas that occurs before it. The easiest way to find this is to find your element, go up 1 period, so go up 1 row, and then go all the way to the end of that period where the noble gases are. Because remember, noble gases are that far right column on your periodic table. You're going to write the symbol for the noble gas in brackets. And then you write whatever part of the electron configuration comes after the brackets. So here's an example. Fluorine. So we find fluorine on the periodic table, atomic number 9. We're going to go up 1 period and to the far right, meaning that our noble gas in this case is helium. So we're at helium, and then we just do our electron configuration moving forward. So you should have gotten helium in brackets, 2s2, 2p5, because fluorine is 5 over in that p orbital. All right, last practice for this video. I want you to practice writing the noble gas configuration for each of these elements. So pause this video and come back when you're done. All right, for chlorine, we find chlorine atomic number 17, which means that neon is the noble gas that occurs before it. And then when we write out the rest of our electron configuration, this should have been your correct answer. For tellurium, it is atomic number 52. So we went up and over to find that the noble gas that comes before it is krypton, and then we did the rest of our electron configuration, finding that it remains 5s2, 4d10, and 5p4. Barium, with atomic number 56, has xenon as our element before it, and it is just the xenon in brackets, 6s2, nice and simple. Think about how long the barium electron configuration would have been the other way. This saves you a ton of time. Now argon, unfortunately, you can't just put argon in brackets. You have to go back to the previous noble gas, which in this case is neon, and then you finish up the rest of your electron configuration. Adding ions into it is no different than doing our ions before. So we find potassium. The +1 means we're going to subtract 1 electron from whatever we end up with. So in this case, we have neon as our one that occurred. Now I know some of you are thinking, Ms. Hinkson, I'm looking at the periodic table. Argon is right before it. But if we subtract 1 electron from potassium, it goes back to being argon. So we have to do the other configuration. So it works out to be the same as argons. Similarly, if we find fluorine, which is a -1, meaning we're going to add 1 electron, we have to go back all the way to helium for our noble gas to make sure that we're doing the configuration correctly. Now I know the last two were a little bit tricky, but make sure you know how to do ions and watch out for the noble gases when it comes to the noble gas configuration. If you have any questions, bring them to class tomorrow. And as always, you can rewatch this video if you need the extra help.